Hello everyone, let us look into power law transformation. Image transformation is an image processing technique where the intensity of the input image is mapped based on the transformation function to their output values. This is basically done to extract the hidden details in an image. Power law transformation is one such transformation with the basic form S equal to C into R to the power gamma, where S is the output pixel value, C is the scaling factor, R is the input pixel value, and gamma is the exponential value. As you can see in the figure, the gamma value can vary in a huge range. Let us consider this gamma is equal to 1 line. Here, as we can see, for an input intensity level, it is mapped to the same level of the output intensity level. Let us consider gamma greater than 1. When we observe now, the higher the input intensity, it is mapped to a lower value. And when the gamma is less than 1, we can see that the lower the input intensity value, the higher it is mapped to in the output intensity. Now, let us see where this can be used. You might have seen that a particular image is displayed differently by different monitors. This is because the display system in a monitor responds according to a power law. The process used to correct these power law responses is called gamma correction, and we perform the gamma correction by power law transformation. For example, let us consider a cathode ray tube. It has an intensity to voltage relation as a power function with the value of exponent around 2.5. So what this means is that the image viewed in the cathode ray tube will be darker than the original image. As we can see, if this is the original image, the image viewed in the cathode ray tube with the exponent value of 2.5 would be like this. When we perform the gamma correction on the original image, it will become like this. We get the gamma corrected image. When we view the gamma corrected image in the cathode ray tube, it will look like the original image that was supposed to look like. So this is done by performing the power law transformation with the exponent being the reciprocal of the gamma factor of the display system, that is 1 by 2.5 in this case. Let us consider this MRI scan of the upper thoracic human spine with a fracture dislocation. Now, as we can see that some of the areas are dark and we cannot extract information or understand anything about the image. But this can be eradicated by performing power law transformation. Like we can use the transformation with exponent values less than 1, so that the lower level intensity values in the input are mapped to the higher level intensity values on the output. So the darker areas are being made bright. The figure shows the power law transformation with the gamma value of 0.6, 0.4 and 0.3. Now let us see the aerial image of a town. As we can see in the original image, there are many bright pixels. This makes the human eye a bit uncomfortable to distinguish between things. Now, if we perform gamma power law transformation with the exponent value greater than 1, that is, if we map all the brighter pixels to a lower value in the output region, then we will be able to distinguish neatly what is what. So as we can see, this is the output of the power law transformation image with the exponent value of 3.2, 4.2 and 5.2 respectively. I want to conclude by saying that power law transformation can be used to perform gamma correction, and it can be used to play with the contrast of the image and extract details from it. And with the exponent value greater than 1, the image darkens, and with the exponent value less than 1, the image brightens up. Thank you.